Hi guys, greetings to you all. Today I would like us to look at hypothesis testing. Talking about hypothesis, what is a hypothesis? A hypothesis is simply defined as a claim or statement about a population parameter. A claim that when stated needs to be verified. And talking about hypothesis, we have two types of hypothesis. We have the null hypothesis and the alternative hypothesis. The null hypothesis is simply the status quo. It states the status quo, the present situation. It is the hypothesis to be tested. And the alternative hypothesis represents any change in the status quo. It is a hypothesis which is accepted when the null hypothesis is rejected. So talking about hypothesis testing, we'll come across terms like the critical region, also called the rejection region. And this critical region is a set of values that leads to the rejection of the null hypothesis in favor of the alternative hypothesis. The set of values that leads to the rejection of the null hypothesis. Take note, in favor of the alternative hypothesis. We equally have a critical value or values, which is the value separates the critical region from the acceptance region. Likewise, we'll be calculating hypothesis testing hypothesis, we need to know what means the level of significance that we'll be using, which is denoted by alpha. The level of significance is simply the probability of making a type 1 error. That is, the probability of rejecting the null hypothesis when it is true. Okay, that is the level of significance that will give. You can be stated 5%, 1% level of significance, because you are like saying that okay, you can commit a type 1 error. The probability that you commit a type 1 error is 5%, is 1%, is 2%. Alright, that said, we equally have two tests. We have a two-tailed test and a one-tailed test when testing hypothesis. This one for example is a one-tailed test with less than here. This one is also a one-tailed test. This one you see two sides there, is a two-tailed test. So H1 here is representing the alternative hypothesis, H1. You see this first diagram to the left is when we are testing when a hypothesis that involves a decrease. Okay, when there is a decrease, the alternative hypothesis is talking about a decrease. This one is talking about an increase, and this one you will hear, the third one you will hear about a change, and the change that was not equal to the alternative hypothesis. The population mean not equal to mu0. Here greater than, you see here less than. Those are the different shapes. Now, that said, we'll go straight to see how to test some hypotheses using examples. Okay, we'll look at example 1. Jars of honey are filled by a machine. It has been found that the quantity of honey in a jar has mean weight of 420.5 grams with standard deviation of Standard deviation here, yes, 3.2. The machine settings are altered. Though the standard deviation is unaltered, it is believed that the mean quantity may have changed. The mean quantity may have changed. A random sample of 50 jars is thus taken, and the mean quantity of honey per jar is found to be 421.4 grams. Carry out a test at 5% level of significance, stating suitable null and alternative hypothesis. Okay, that's it. I've underlined the keywords. We'll look at the solution. Now, the hypothesis. How do you obtain the hypothesis? The null hypothesis. A jar has mean weight of 420.5. So that is our H0. H0 mean weight of 420.5 grams. Yes. Then the alternative hypothesis. The alternative hypothesis, mean quantity may have changed. The mean quantity may have changed. It means mu is not equal to, okay, is not equal to 420.5 grams. That's what I mean by the mean quantity may have changed. Alright, so that's the null hypothesis, that's the alternative hypothesis. Equally here, we have that the level of significance is 5%. If the level of significance is 5%, right, and take note, when it has changed, mu not equal to, means we are talking about a two-tailed test. So here it means this alpha 5% will instead be, we are talking about z alpha over 2. We're talking about alpha over 2 here. So it will be z 0.025, okay, because of that. Now, and the z value here, for us to obtain the probability here, it will be probability z less than z 0.025, which will give us 1 minus 0.025, which is 0.975. But when you go to our table to obtain the critical value, we see that the value for z.025 at a probability of 0.975 is 1.960. So this one is the critical value that we're going to use to test. Okay. So having stated the various hypotheses, having stated and having obtained a critical value, we go straight to obtaining our z. Z is x bar minus mu divided by sigma over root n. And from our question already, we have z bar, which I underline 421.4 minus 420.5 divided by standard deviation 3.2 over square root of 50. When you do that, it gives us 1.989. 1.989. Now, so this value is to be compared with the critical value which we had 1.960. So we see that since 1.989 greater than the critical value 1.960, what do? This implies that we reject H0. We reject the null hypothesis. Reject H0. And when we reject H0, it simply implies that there is evidence that at 5% significance level, the mean quantity of honey per jar must have changed. Okay, the mean quantity must have changed. Okay, thank you. But we'll look at another example, the second example. Okay, just to reiterate on how the critical value is obtained. You will go to your critical values for the normal distribution table. There is a p value, there is a z value. Okay, now you will see now when it is a two-tail, like the case we have here, we have 5% level of significance. At 5% level, two-tail, this is how we obtain the z value. 5%, you divide by 5% by 2. Okay, when you divide the 5%, you are going to have 2.5%. Now, you subtract 100 minus 2.5, will give us 97.5%. And 97.5% is the same as 0.975. You go to your table, you check the z value for 0.975. You will go and see here, you see 0.975. This is the z value. That helps us to give the decision, the critical value. So if the z that we calculate is greater than this, we reject. Since it's a two-tail, if it is greater, we reject. If it is below for the negative 1.96, likewise we will still reject. Okay, let's look at an example of a one-tail test. Okay, let's look at another example here. We have that the proprietor of Northern Provision Center complains that of recent, the average mass of sachets of detergent supplied by a certain company is less than the stated value of 100 grams. In order to investigate the proprietor's complaint, the company took a sample of 100 sachets and realized that their mean mass was 99.889 grams with a standard deviation of 0.7. By using this information, determine at the 5% level of significance if the proprietor's complaint is justified. Okay, our solution. The very important term that we've learned that it is less than. So it means we are talking about a one-tail test, and one-tail test to the left. Less than, if it was greater than, we are talking about H1 being to the right. So here, it simply means our H0, that's the null hypothesis, H0, our H0, the mu is stated value of 100, that's the status quo. Mu is equal to 100 gram. Then H1, which is the null hypothesis, they say less than. So mu, our null hypothesis, mu less than 100 gram. That's our null hypothesis. And what are the ingredients that we have here? We have n is equal to 100. Okay, we equally have x bar equal to 99.88 grams. We equally have sigma equal to 0.7 gram. So, and our z value, how do we calculate our z value? To know the z value, now it is one tail. So at 5%, one tail, we are not dividing that alpha by 2 again. At 5% means 1 minus 5% is how many? 95%. And our 95% is the same as 0.95. When you go to your table, you will have like this. You have the p value, you have the z, you have 0.95. You will see below it 1.645. That's our critical value that we'll use for the test. So if we calculate our z value, we are going to use this. Since it is to the left, we are going to use negative 1.645. This is our z alpha. That's our z alpha. Okay, let's calculate our z. Our z x bar is 9.88 minus 100 divided by 0.7 over square root of 100. When you evaluate that, it gives us negative 1.71. Negative 1.71, which gives us negative 1.71. That's our z value, since it was to the left. And our this is the z that we've calculated. Now, being to the left, as I said, it is negative. It will now be negative 1.645. We will now see that negative 1.71. Our z is negative 1.645. So having negative 1.71 less than negative 1.645, it means our H0 is rejected, and so the manager's claim is true. We conclude that the manager's claim is true. Our H0 is rejected, and we conclude that the manager's claim is true. So that is how we test hypothesis. Okay, thank you for your keen attention. See you in subsequent videos for more on estimation theories, confidence interval. Thank you. Have a great time.